Have you ever wondered what would happen if time itself started glitching? Picture this. You're on a flight, the cabin hums, and the flight clock on the panel ticks backwards for a few seconds. Your wristwatch freezes. The GPS readout flickers and then corrects itself. It sounds like science fiction, but variations of these events have been reported by real pilots and passengers. In this video, we'll explore the science behind so-called time glitches and other unexplained aviation phenomena, what physics says, which instruments are involved, real incidents people have described, and why some researchers bring up ideas like parallel timelines. Stay with me as we separate well-established science from sensational stories and show how gravity, speed, and modern technology can produce surprising effects. Let's start with what physicists mean by a time glitch. Einstein taught us that time is part of space-time and is not absolute. Two key effects change how time is experienced: special relativity, which links time to relative speed, and general relativity, which links time to gravity. In simple terms, a moving clock ticks more slowly compared to a stationary one. That's time dilation from speed. Likewise, a clock deeper in a gravitational well ticks more slowly than one higher up. That's gravitational time dilation. These effects are tiny at everyday speeds and gravity differences, but they are real and measurable. For example, astronauts on the International Space Station age microseconds differently than people on Earth. The term time glitch is often used when instruments or observers briefly record an unexpected timestamp or a mismatch between clocks. Physicists would interpret most of these as synchronization issues, local relativistic effects, or electromagnetic interference, not sudden rewrites of causal order. To make it relatable, imagine two synchronized stopwatches, one carried in a fast car and one left at home. After a long drive, the car's watch will lag by a tiny amount. Now scale that up with aircraft speeds, higher altitudes, and precise atomic clocks, and you get measurable discrepancies. When unexpected readings occur, researchers look for environmental causes first: abrupt accelerations, magnetic disturbances, or software bugs that can mimic a glitchy timeline. Aviation is a prime setting for these reports because airliners and jets operate at high speed and altitude and rely on many synchronized systems. Pilots have occasionally reported clocks freezing, instruments displaying inconsistent time, or brief GPS anomalies. One often cited 1985 incident involved crew reports of a time bubble over the Atlantic. They described instruments showing odd time jumps for seconds before systems resynchronized. Aviation authorities investigated and typically found correlating environmental or system log clues: brief power transients, software resets, or errant sensor inputs. Other cases involve cockpit clocks disagreeing with passenger watches or ground systems during rapid changes in the flight state, such as sudden climbs, turbulence, or electrical switching. It's important to note, pilots and crews sometimes use multiple time sources: wristwatches, cockpit clocks, flight data timestamps, and GPS time. When these diverge, it can feel dramatic, but it usually points to synchronization differences rather than a literal reversal of time. Still, these reports matter because they prompt deeper checks into instrumentation resilience and maintenance procedures, ensuring safety is never compromised by timing anomalies. The modern aviation ecosystem depends heavily on GPS and precise timing. GPS satellites carry atomic clocks and orbit at about 20,000 kilometers, experiencing weaker gravity and moving quickly relative to Earth. Engineers must apply relativistic corrections to satellite clocks so GPS positions and times remain accurate for users on the ground and in the air. If those corrections were wrong, or a receiver lost lock temporarily, you'd see jumps or freezes in reported time and position. On aircraft, onboard systems compare GPS time with internal clocks. Local gravity variations, from dense geological formations or even large weather systems, slightly perturb the gravitational field, though usually by negligible amounts. More impactful are electromagnetic disturbances like solar storms or multipath effects where signals reflect off surfaces, causing transient GPS errors. Flight systems are designed with redundancy, filtering, and error checking to smooth these glitches. But under rare conditions, you can still get a visible hiccup. Technicians then comb logs, compare satellite telemetry, and check for software or hardware faults to pinpoint the root cause. Why do some people jump from glitches to parallel timelines or dimensional boundaries? It's an appealing narrative. An unusual observation invites an extraordinary explanation. Some speculative theories in fringe literature suggest brief intersections between alternate branches of spacetime could produce mismatched physical constants or timestamps. Mainstream science demands testable predictions and reproducible data. So far, parallel timeline claims lack the controlled evidence required. That said, the mystery around reported aviation time anomalies has value. It drives better instrumentation, more rigorous data logging, and clearer communication among flight crews and engineers. So next time you hear about a clock going back on a flight, remember there are plausible physical reasons: relativity, synchronization errors, software quirks, or electromagnetic interference, and there's ongoing work to understand and prevent them. If you found this exploration intriguing, like and subscribe for more deep dives into physics and aviation mysteries. Thanks for watching, and keep an eye on that clock.